Hi everybody, today in this video we'll learn Snell's law. Here as we studied Snell's law include n1 times sine theta 1 equal n2 sine theta 2. What does it mean n1? The index of first medium, here medium number 1. Okay, what is n2? The index of second medium, or the incident light located in n1 in first medium, the refracted ray located in medium number 2. So incident ray, the rays coming from the first medium, then enter to the second medium, N2. So from N1 to N2, from N1 to N2. Okay. Here, what is theta 1 or theta I? Theta 1. This is angle of incident, the angle between normal and incident ray. What is theta 2? This is angle of refraction, this angle located between two rays, normal and refracted light. Okay. So Snell put this rule n1 times sine theta 1 equal n2 times sine theta 2 in order to find n1 or n2 or theta 1 or theta 2. We have 4 factors. If you know 3 factors, you can find the others. Okay, the fourth factors. Okay, let we go to the second slide here. Here, what is the conditions of refraction? Many times we discussed this subject many times. We said about conditions of refraction many texts, but here we put 3 texts. This is very necessary. The student should memorize 3 conditions of refraction. So number 1, should exist 2 different mediums. What does it mean? For example, we have air and glass, or glass and glycerin, or glass and diamond. So this is 2 different medium, very necessary in order to refraction happen. Number 2, should 2 different medium be transparent? What does it mean transparent? Not metal, okay, not dark, should be transparent, like air, like glass, okay, like glycerine liquid, should be transparent. Because suppose you don't have transparent, so how we can say, how we can see the reflected ray and incident ray should be transparent. Okay, Number 3. Should incident ray be inclined figure, not along the normal? When we have incident ray, this incident ray should make angle with normal. Angle, okay? Angle between 1 degree until 89 degree. So we have to do angle between normal and incident ray, not zero angle. Zero angle, that is mean the incident ray along the normal with direction of normal. So this is not inclined. Should incident ray be inclined? Okay. Now we have to go to the another slide. In this slide, we have more explain about two rules of refraction. Two rules of refraction. Or when the situation be bent away and the situation when be bent toward the normal. So here we discuss when the situation it is bent away, when the situation it is bent toward. Number 1. So number 1 is rule number 1. Number 2, rule number 2. Okay. If you do random, no problem. Okay. If from low index, that is mean the incident ray comes from low index, and when low than or smaller than n2. So like, give me example, like if you coming from air, which is n equal 1, to glass, which is n equal 1.6. So this is from low index to high index. So what about reflected ray? Refracted ray. So what about refracted ray? The ray bent toward refracted ray bent toward the normal. Okay, this is number 1. Of course, in this case, when we say n1 less than n2, that is mean theta 1 greater than theta 2. Theta 1 greater than theta 2. So this is bent toward. Again, for example, the incident ray makes 30 degree with normal, 30 degree. Don't forget, this is air. That's medium 1, air. When enters to medium 2, glass, n2 equal 1.6, so in this case, what do you expect about theta 2? Should be less. Why? Because this is bent toward. This is, it will be less than 30. Less than 30. Maybe 25, maybe 20. Should be less. Okay, why? Because this rule said bent toward. When we have bend toward situation, that is mean theta 2 less than theta 1. Okay, number 2. If the incident ray comes from high index, then enter to low index. Here we opposite the situation. For example, the first medium is glass, then the incident ray comes from glass and 1 equal 1.6, then enters to air 1.1. So this is 1 and 2 air. In this case, we have different situation. We have bent away. Of course, bent away, that is mean in the second rule, theta 1 less than theta 2, or theta 2 greater than theta 1, because this is bent away situation. Don't forget these two rules, because we need them to solve practice in page 147 or section review. Again, if we come from a low index, then enter to high index, the situation bend toward, or n1 less than n2, that is mean theta 2 less than theta 1. Number 2, if we comes from high index, then enter to low index. In this case, we have bent away, or n1 greater than n2, that is mean theta 2 greater than theta 1. Okay. Here we have another slide. In your book, page 147, we have sample problem 6a. If we read this question or this sample problem, Snell's law, a light ray of wavelength 589 nanometer produced by sodium lamp. So all this sentence, this is data. We don't need this data. We don't need wavelength. Just because you need to understand, is this ray monochromatic, and it has one wave, unique wavelength. That is why he said by sodium lamp. So we don't need these data with Snell's law. Only for student more understand about the source of light. We need to another data. Traveling, he said, traveling through air strikes a smooth flat slab of crown glass. See, here he determined which is first. He determined which is first medium and which is second medium. First medium, air, see, and 1 equal 1. Second medium, he said, crown glass. we have flat glass and crown glass. In your book, we have table 1, 6. In this table, there is many substance index. Now, when he said from air, so N1 equal 1, this is given, N R equal 1.52. This is glass, crown glass. He said an angle of 30 degree to the normal. So this is theta I, an angle 30 to the normal. Find the angle of refraction. Of course, the 3 factors given here with solution. Theta I 30 degree, and I 1, and R 1.5. What is unknown? Theta R unknown. Put plan. In this subject, we have one plan, we have one rule. This is this equation for Snell's law. Combine 4 factors, 1 factor unknown. Look here, Ni sine theta I equal Nr sine theta R. No problem if you said if you say N1 theta 1 and 2 theta 2, no problem. Okay. Here he simplified because angle unknown. We don't need to sine theta r. We need to theta r. So in this case, you have to take sine inverse. Sine inverse. By click your calculator, shift, then click sine. In this case, the answer should be 90.2 degree. This is sample problem. Here question 2. In question 2, for an incoming ray of light of vacuum wavelength 589, this is source of sodium lamp, of course, but we don't need this. We don't need this. Okay. Fill in the unknown. Fill in the unknown values in the following table. Again, he said use table 6.1 to find unknown. I prepared this here. I prepared a new table for you, but let we read question 3, because question 2 it will be homework for you. Question 3, array of light of vacuum wavelength 550 nanometer traveling all these extra information in air. See, this is important. In air, so N1 equal 1 enters a slab of transparent, look, transparent material. This, if you remember, the condition of refraction is one condition is transparent, should be transparent material. The incoming ray makes an angle 40. So here, of course, you have theta 1 equal 40 with the normal, and the refracted ray makes an angle of 26. So theta 1 and theta 2 given with the normal. Find the index of refraction. Again, he said, find the index of refraction. So what is unknown? Index of refraction. The unknown is N2, which is transparent material. We don't know which type of material. So with or within the Snell's law, you can find which this transparent material. You can find N2. Find the index of refraction of the transparent material. Assume that the index of refraction of air for light equal 1. Okay? So this is directly use Snell's law. As I said, we need to N1, theta 1, theta 2. N2 unknown. N2 unknown. Let we discuss the table, question 2, in the next slide. This is question 2. Use the table, page 144. Why? Because sometimes we need N1 or N2. Okay. With first row here, you have 25. This is theta 1, 1.66. This is N1, and theta 2 unknown, N2 1.52. So you practice with Snell's law. We do practice. We have to do practice with Snell's law 3 times, 3 questions. So we applicate Snell's law 3 times with A and B and C. This is last slide about section review, page 100 in your book, page 147. Question 1. Sunlight passes into raindrop at angle 22.5. Of course, from air go to the water. So here we have N1, we have N2, and 22.5. What is unknown? Of course, angle of refraction unknown. Angle of refraction is unknown. He said, what is the angle of refraction? Use Snell's law. N1 sine theta 1 equal N2 sine theta 2. What is unknown? Theta 2. Tell me about N1. 1, because come from air. Okay. N2 1.33, because this is water. Okay. Question 2. I answered question 2, but let we discuss this. For each of the following case, for each of the following cases, will light rays will light rays be bent toward or away from the normal? So here he discussed the two rules of refraction. I said number one, or number A, if Ni greater than Nr, so the incident ray comes from high index, then enter to low index. Of course, this is bent away. B, if Ni less than Nr, that is mean the incoming ray from low index enters to high index. In this case, we have bent toward situation B. In the yellow box, you see the answer. Okay, C, from air to glass, you know air 1, you know glass 1.6 or 1.5, no problem. Anyway, index of glass greater than index of air. So what does it mean? That is mean we coming from low to high. So here Ni less than Nr. In this case, the situation is bent towards. Okay. D, from glass to air. That is mean from high density or high index to low index. So first one, Ni or N1 is greater than N2, like A. In this case, we have bent away situation. Question 3. Find the angle of refraction of a ray of light that enters a diamond from air. See, he said diamond. So diamond, second medium. Okay, what about air? First, why? He said from air. So air, then enter to diamond at an angle of 15 degree. So what is unknown? Find the angle of refraction. So theta 2 unknown. He said use the table. When we use the table, N1, which is air, equal 1. N2, which is diamond, equal 2.4. Okay, theta 1 equal 15. What is unknown? Theta 2 inside diamond. Of course, what do you expect about this question? I expect, because we are coming from air, which is low, to the enter to the diamond, which is high, from low to high. In this case, we have bent toward. So the angle should be less than 15. Solve this question, then tell me. in this question, we have critical thinking. In which of the following situation will light from a laser be refracted? Why he said laser? Laser because I said, guys, we need to the monochromatic light. We don't have here the refraction should be used monochromatic wavelength. The source of light should be one wavelength. That is why we use laser. Okay, anyway, we have source of light is laser. A, traveling from air into diamond at an angle 30, like question 3, exactly. From laser light coming from air, then enter to the diamond with 30 angle. So in this case, I put answer A. That is satisfied. It will happen, refraction, because all conditions exist. Two different medium. Index. Number 2, transparent. Air and diamond transparent. Number 3, the angle is 30, so this is inclined. And you make angle with normal. So all conditions of refraction exist. So A, look at this star, red star, A is true or satisfied. B, traveling from water into ice along the normal. He said along the normal and without angle. So here I have first question exist. Water, ice, different medium. Okay. And I have two mediums transparent, but one condition not satisfied. He said along the normal, and the angle equals 0. This is not here. Refraction not happen here. C, upon sticking a metal surface. He said metal surface. Here, guys, listen. He said metal surface, not metal transparent surface. So that is why the medium not transparent. So in this case, C also not satisfied. The last one,